Hello everybody, here we are, 4.7 surface area of a right cylinder. The objectives, the students will develop and use a formula to calculate the surface area of a right cylinder. If you could start with these two definitions, that'd be great. So please write these down, definition of radius and definition of diameter. So the radius is a line segment from the center of a circle to the perimeter. So for example, this is a radius right here. It goes from the very center of the circle to any dot on the outside of the perimeter of the circle. And diameter, this is a diameter. This is a line segment that passes through the center of a circle. So it goes from one side to the other, and it's a straight line, and it passes exactly through the center. So it could be, any number of these. They're all diameters. They pass through the center if you draw it correctly. So if you could write down those two definitions to start. And so to find the surface area of our cylinders, we're going to need to deal with some radius and diameter. You'll need to be able to go from radius to diameter and diameter to radius, and you have to know how to use a formula. So let's start. Part of finding the surface area of a right cylinder is being able to find the area of a circle. And we have a formula for that, which is that the area of a circle equals pi times r squared. And that's not pi times r squared. It is like pi times r squared. So not pi times r and then squared. It's pi times radius squared. And pi is, as I pointed out, I think in our bell work, an irrational number, goes on and on forever in a non-repeating fashion. It's the relationship between the diameter and the circumference of a circle. So diameter times pi equals the circumference. And it's 3.141592 something 63. But kind of is infinite. So those are all the digits I remember. Often you'll see it written as just 3.14. And I'll use that today because I think my computer calculator doesn't have a pi button. Though most of your calculators will have a pi button. So let's do our first example of inputting a value into our formula and solving for area. So we're trying to find currently the area of this circle. We know the radius and we know what pi is, so we'll be able to find it out. So area equals pi times radius, right here, 30 squared. So area equals, I'll need my calculator. Oh, I already have it up. So I'm just going to use 3.14 times, I don't think I have brackets because I would need to put this in brackets, but I know that 30 times 30 is 900. So 2826, and it's millimeters squared. Remember, we're looking for surface area. It's a two-dimensional shape, so we put the squared there. Sometimes the radius is not given, but the diameter is. So we'll need to know the relationship between these two pieces of information. In that case, you have to divide the diameter in half to get the radius, so you can use the formula. So what we know that radius equals a half the diameter. So let's figure this out. The diameter is 20, so radius equals 1/2 times 20. So radius is going to equal 10. So let's do it. Pi, now we know that r equals 10, so we can go 10 squared. Pi times 10 squared, or 10 times 10 is 100. 3.14 times 100 gives us, I think, 314. There you go. 314 looks like meters squared. And I have it highlighted here. Maybe it'd be good for you to highlight that the diameter is the radius doubled and that the radius is half of the diameter. So 2r equals diameter, and 1/2 of the diameter equals r. Let's move on to a question. The first step is to create a net of the following cylinder. I think in the very beginning we did some nets of cylinders, so let's draw one now. So we have our top and bottom circle. So there's a circle here. There's a circle at the bottom. And then we have this long part. If you think about it, I'm going to call it later in our notes a label. And I do that because I always think about a can, a soup can. Here's the can. And if you've pulled off the label, oh dear. Whoops, okay. So if you pulled off the label, it looks something like this. And it would end up being a rectangular shape that goes around the outside of the can. So the net looks something like this. Here it tells us the radius, so the distance from the center of the circle to the perimeter is 4 centimeters. And it tells us that the height of the can would be 10 centimeters. And this is a length we don't quite know yet. So that's going to be one of the first things that we learn about is how to find out the length of the rectangular part of our cylinder shape. And if you think about it, well, I mean, I guess we'll get there. But so let's scroll down and I'll show you that part. So our goal is to find the surface area of the cylinder. Let's break it up into the parts we have to find. So we got to find these two circle, this bottom circle, and we have to find that kind of label part of our cylinder. So for the label, the length of the label equals the circumference of the top. So if you think about it, here, I'm going to use a different color. Here's the circumference of this circle. And if you rolled this at every point, this part right here would touch along the outside of this circle. So this line right here is the circumference of the circle. Circle. So you're always going to have to find that out to find the length of our label. So there's another formula we're going to have to learn. And this is all on our formula sheet, so that's okay. That the circumference equals pi times diameter. You could also write this as 2 pi r. Remember that twice of the radius is the diameter, so you might see it as pi times d, and you might see it as 2 pi r. So the circumference in our example is pi times the diameter. Let's look. Here it gives us radius, which is 4. And we know that to get the diameter, we need to double that, so times 8. Now let's use our calculator. 3.14 times 8 equals 25.12. And I think this is, sorry to scroll so much, centimeters. Okay, so now we know the length of this label. We now know that this is 25.12 centimeters. It's the circumference of that circle is the length of this rectangle, and that's the height of our rectangle, or the width. So now let's find the label. We just found the length, 25.12, and we're going to times it by 10, which is already labeled for us on our example. And so that's going to be 251.2 centimeters squared. It's an area. It's two-dimensional. Has both length and width. Okay. And now let's look at the area of our circle. Okay, so we've got two circles. We have to find the area of each of them. They're congruent, so they're the same. Let's use our formula to find the area of each of the circles, or one of the circles, and times it by 2. So we have another formula that area of a circle equals pi r squared. Oh, we had that up top, my bad. So we've already gone over this. So let's do it. Pi times r, our radius here is 4 squared. And let's use my calculator. 3.14 times 4 squared, remember, is 16. That gives us 50.24. Centimeters squared. And we need to times this by 2 because remember there's two circles. So let's go times 2 equals 100, 100.48 centimeters squared. And now we have a kind of last step, the total surface area of the parts. So the surface area of the label, 251.2, plus the surface area of the bottom and the top circle, 100.48. And let's add those together. Plus 251.2 equals 351.68. And that's centimeters squared. Remember, it's a two-dimensional object. That's why it's got the little 2 there. It's squared, 2 dimensions. And there we go. So now let's do another example together. What's the surface area of the following cylinder? We know the radius and we know the height. So we got another, looks something like this, something like this. We know the radius is 6 centimeters. We know the height here is 5 centimeters. We don't know this yet. That's going to be our circumference, which we know is pi times diameter, or 2 pi r. So let's find the surface area of all of these parts and add them all up. So the label, first let's find the circumference. So circumference equals pi times diameter. So the circumference equals pi times our radius is 6. So that means the diameter is 12. That equals 3.14 times 12 equals 37.68. So now we've solved this mystery right here. We know this is 37.68 centimeters. So to get this surface area right here, now we got length times width. We can go 37.68 times 5. So now length times width equals 37.68 times 5. And the area of our label equals, here we go, times 5 equals 188.4. I think that was centimeters squared. And now let's look at our two circles. Remember the area of a circle equals pi r squared. So area of a circle equals pi times our radius was 6 squared. So the area of our circle equals 3.14 times 6 squared is 36. So we got 113.04 centimeters squared. There's two circles, remember? Sorry, two circles. So we have this one right here and this one right here. So we have to times that by 2. So 113.04 times 2 equals 226.08. Oops, 226.08 centimeters squared. So now let's add them up. It equals 188.4 plus 226.08. I keep on hitting this with my arm. Sorry, everybody. I'm going to blame the new computer or else human error, but I'd rather blame technology. Okay, and let's add them up. 26.08 plus 188.4 equals 414.48. And that's centimeters squared. It's a two-dimensional object, so centimeters squared. I might get you folks to try this one on your own, and then I'll go over it in class. And And so I'll keep on going. So I'll pause. I can do this one with you live, and then I'll just move on to the next